Hello, hi, namaste. I welcome you all to my channel. Myself Raju Hegde. Today we are going to learn about supervised machine learning, one of the most used method in machine learning. Classical machine learning is divided into two major categories, supervised and unsupervised. We also have semi-supervised and reinforcement learning. In this tutorial, let's look into supervised learning in detail. I have taken this picture from Simplilearn. It's very much self-explanatory. We are feeding machine with data, different type of data, and data will segregate or learn from this particular data. Then later, when you feed new data to the machine will segregate this particular data to the respective classes or groups. So this is all about supervised machine learning. It's labeled. These two are labeled and machine will act accordingly. If you want a machine learning algorithm to solve a problem, you must first train it. Unlike humans, you do not teach a machine in classroom, correct? You teach machines using training data. This is what the training data is. Essentially, training data are past examples showing the machine how to solve problem. Using your chosen algorithm, the machine works through all these examples and understand how to solve them. If you use very specific examples, the machine will only be able to solve very similar problems. But if you use very large and broad training data, your machine will learn how to solve a wide range of diverse problems. As I mentioned in my earlier video, an example of reading books. If you read more books, you will be in a position to have more knowledge on the subject. Although there are many different ML algorithms you can use, these can all be grouped into two main classes, supervised and unsupervised. The only difference supervised and unsupervised learning lies in the type of training data you use. So supervised is labeled data. So machine will learn under supervision. It's very simple. What is supervised learning? Machine will learn under supervision. Supervisor will teach machine with large number of cat and dog pictures. That means labeled data. Machine will learn from these pictures and identify new picture whether it's a cat or a dog. Very simple. But here the difference is machine will learn fast under supervision. That is the reason this is used in many real life cases. What happens is, like, when you are learning a new language, we'll take example of new language. You are learning a new language. That time the trainer will give a vocabulary of that particular language with the meaning in English to you. For example, we are learning German, and all the German words with English meaning he'll give it to you. Then you are reading that. But in machine, this happens very fast. You are feeding all this vocabulary to the machine. Then later, when you feed the language sentence of machine of English, it will translate it to German. So machine will learn very fast. That's the reason we are using ML for many real life problems. There are two types of tasks: classification and regression under supervision. Classification used for categorical output. Regression is for numerical output. Okay. So let's see a little bit more details into classification and regression. Before discussing about the details and applications of each algorithm, let's see the difference. In one of the book by Joshua Chapman mentioned that in the industry's real problems in computational analytics, over 80% of the models were classifications, and only 15 to 20% were regressions based on his experience. We may get questions inside our mind, why classification is highly used. As you mentioned in the slide, classification results has got clearly defined boundaries or categories or groups. This will help user to make clear decisions. For example, in the industry cases, should I participate in the upcoming trade show or not? The regression model might reply, yes, we have received 25% new sales from the previous show. Whereas classification might say, yes, we have good conversion rate. So in these two situations, like, we will go with the classifications. The decision is very clear. So classification model helps us to make decisions. That's the reason people use classification more. So examples are something like, in the real life situations, the classifications examples: spam, ham, or divide separate fruits by color, divide hospitals by specialization, documents based on language. So there are many applications like that. And classification, if it is only two types, is called binary, and if it is more than two types, is called as multi-class classification. And there are many popular algorithms used for this: name based, decision tree, logistic regression, k-nearest. We'll get into all these algorithms in detail in my future classes. Regression is basically classification where we focus on numbers instead of category. Regression is the task of predicting a continuous quantity or numbers. So the regression is ideal for something depends on time: car price by its age, sales forecast, traffic by time of the day. These are all time bounded problems. So for this, regression is very much useful. So in regression we have two types. One is linear and another one is polynomial regression. When line is straight, it's linear regression, and when line is curved, it's called polynomial regression. These are the two types of regression. Okay, so in this video we have covered supervised machine learning and types of supervised learning, so machine learning, classification, regression, and again what are the different types of classification and what are the different types of regression. So in my next video we will learn about unsupervised machine learning and types of unsupervised learning. In detail we'll learn. So thanks for watching my video. Have a nice day. Thank you.